Hello friends, today I am going to discuss some explanations like a polynomial. So I think before that I have to do some settings, so please wait 1 minute. I have to go to like a so open setting. No. Wait 1 minute please. Sound settings, so I have to do something like this. It's a volume like a need to the increase here. Yeah, it's alright. Like a advanced setting, sound manager, and it's a store and go back. It's a device properties. Yeah, it's right. Most of the time just I am getting a problem. Okay, so hello friends, just today I am going to discuss some draw the graphs of the polynomials. So polynomial graph you can draw like a linear equations, like a quadratic equation. So first I like to describe this graphs you can draw with the pythons. So let's see here. If I am writing like a equations fx, it's a will equal to 2x minus 5. So this means it also represent like a y will equal to 2x minus 5, and this graph will be like a it's a linear equation. So we can draw like a box. This one can represent like a x, another can represent like a y, and you can take like a it's a minus 1 value of the x, then it becomes minus, it's a minus 1 value of the x. So yeah, you can put here the plus 1, then it will be like a minus 3, and similarly if you put like a 4, it becomes a 3, and we can plot a one single straight line. So I will discuss how do we plot single line like as a straight line. Similarly, the second equation should be like another polynomial like a quadratic. So if I write like a fx will equal to x square minus 2x minus 8, and similarly I write here y will equal to x square minus 2x minus 8, and we can plot the another table. It's a look like a parabola, it's a curve look like a parabola. So it's a parabola, and same if you write here like a fx will equal to like if you are putting like a negative value of the a like a minus x square minus 2x and plus 3, so your graph will be look like a this, and it will be look like a it's a like this. So because a is lesser than 1, but if you want to put like a on the x-axis, so your equation should be like a fx will equal to x square minus 6x and it's a plus 9. So it's a coefficient like x square in the fx, a positive real number. So the parabola open upward, and both value will be equal like and another you can like if you are writing like minus 4x square, it's a minus 4x square plus 4x plus 1. This equation look like a you can it's a previous, you can go like this, and this equation look like a like this. So these are the different. So first if the coefficient is a positive, it's a different graph. Like if the means we can make like a positive curve graphs, and if the coefficient like a x square is the negative, it's a negative real number, so the parabola opens downwards. And if the factorizations into the like a two equal factor, so the parabola cuts the x-axis at the two coincident points having coordinates like you can draw the different way. Similarly, the if the polynomial like fx will equal to minus 4x square plus 4x minus 1, so has a two equal roots, so parabola touches x-axis at one point and it cuts x-axis at coincident point. So let's see here. So now let's try, it's a programming language like this. So first it's a we need to also get like a range and domain. We are putting as a value of the x, and I am getting a output like a y, value of the y. So putting a x means it's a domain, and I am getting a value of y, it's a range. And so many times it's a range and codomain both are equal, but it's not necessary always. So let's see here. First I need to the import here, import numpy h. So it has been imported, and I want to the like plot something. So we need to import matplotlib.pyplot as plt. So it has been imported. So now let's go import matplotlib lib.pyplot plot as plt. As plt, and let's write equation. It's the name of this equation like if I am writing here the function x will equal to x should be equal to 3x plus 1. So first we need to create a linspace. So x should be that x should be a it's a variable, x will equal to np dot linspace minus 5 comma 5 1 0 0 1. And fx will equal to 3x. So let's say fx will equal to 3 into x plus 1. And now plot. It's a plt dot plot, not only the plot. So it's a plt dot plot. I want to the plot like a x comma fx. So fx. So let's see here what happened. So we can see it's a plot look like this. It's above the x 0, below the 0 it's a line here, and it's above the 0 here, and line will start like a -4, -2, and 0, 2, and this one. So it's a good way we can it's a x-axis and y-axis, like a we can plot like a it's a y-axis from here. Okay, so I think it's a clear. And that just if I want to plot like a quadratic equation, so it's a different way to we can plot a quadratic equation. It's a linear equation plot. Similarly, I want to plot like a quadratic form. So let's see, just I have an equation like a fx should be equal to, just try it. So I am putting here equation like a fx, it's like a x square. Look here, just I am changing here, it's x square and minus 2x minus 8. Now I want to plot here. So it's a fx square, so I am getting the some problem because I need to put here like a between 2 and x like a multiplication symbol. Now I can plot look like this. So it has been plotted, it's moving from the above the 0, and it's a look like this, and it's a above the 0 you can see here, but if you can see here like in the y-axis it's a represent like a below -5 and it's a above -10, but x-axis it is a going to touch like here. Okay, so the approx value. Similarly, if I am putting like this is the one way, and I am like putting minus x square. Look here, it's a minus x square and minus 2x, and it's a plus 3. So let's see what happened. It's a plus 3. So because the value of a like a coefficient of x square is a negative, so what happened? So if you are taking a coefficient of the a square is less than 1, so we can see here our value, it will start from the -10 and it's going to the upper level, it's near about like a 4, and it's moving the downward. Let's see. So it's a better way we can like apply a simpy, so don't worry. Next I want to plot like this, means we have, if I am getting a like a two equal value, like a value of zeros, like a two equal value. So how do we get, so like a x square, and if I write like equation like a minus 6x and plus 9. Now I want to plot. It's a plus 9. Look this here. Something, yeah, it's a not a negative value, it's a, I am taking a positive value. So look here, yeah, it's right. So you can see here it's a moving like a minus 6x and it's a plus 9. Look like this. And just if you are taking like a minus 4x square, so look, it's a minus 4x square and a plus 4x. So let's go here. It's a 4x and minus 1, minus 1. Then I want to plot like this. Yeah, it's a star. So I want to plot like this. It's a moving from the 0. So you can say it's a moving from zeros. So these are the different types of the polynomials. Now if I am going to the right here minus 3x square. Similarly, if I write like a minus 3x square and it's a minus 4x and plus 5, like a plus 5, then look like this. It's also moving like a slightly just near about like a 0, and we can say also like a below the 0. And another, it's a 2x square, 2x square minus 4x and it's a plus 5. It's a look like this. It's a moving out like a above 0. So these are the way we can plot a different way. Similarly, how do we plot like a cubic equation? So we have a cubic equation like a y will equal to x cube minus 4x. So should I write here? It's a cubic equation like fx. It's right here. It's a x cube. So let's show x cube minus 4x. 4 times it's a x. Let's try. Yeah. So your cubic equations look like this, and if you are x cube minus 2x square, like you are putting x cube minus it's 2 and like x square. So what happened? It's like this. It's like this, means you can see here it's touching on the x-axis like a 2. 2 point. So I hope it's your concept has been clear. Similarly, if you write only the x cube, so what happens just if you are going to plot like a x cube like this. So it's a touching, it's a passing through the like a origin. So these are the number of ways we can understand like a to plot x-axis like linear equations, quadratic equations, and these other functions. Now I want to like discuss to how do we plot the other sections like one of the also like how do we get a value of f o g o f. So if I want to find like a GOF, FOG, so I'm going to write here some functions like if I have a functions like fx should be equal to x cube plus 1, x cube plus 1, and now I want to here the define fx return return x to the power 3 plus 1, and next function should be like a gx gx will equal to square root of x plus 2 sqrt x plus 2, and define here gx like a diff gx return np dot sqrt sqrt and x plus 2. And now I want to find a like a and let's go ahead and I want to print here print GOF, it's a parenthesis inside of the parenthesis like a GOF this one, it should be equal to equal comma g parenthesis like f2. Similarly, just I want to print, so let's see here. I am going to the print here, and now I have gotten out value like a 3 point, it's a 31. So GOF, so now if I want to get here like a, it's a one more value, go ahead and copy it and paste here, Control V, and in hands of the GOF I want to get FOG. So FOG and FG, put here F, put here it's a G, and then I want to print here, I have gotten the another value. Similarly, I want to get here, I want to find like a GOG, it's a print, it's a like a GOG, and it's a G and G, like a G, and let's get here. So I have gotten like a, so we can easily find out what is the GOG, what is the GOF, and it's a better way we can analyze here. Next is the exponential form, and one is the another is the logarithm form. So exponential, suppose I am writing like a 8, and similarly we can also write here it should be equal to 2 to the power 3, and 100 10 square, 81 will equal to 3 to the power 4, 0.01 means it should be equal to 10 to the power minus 2. So these are the exponential, and 10 is the base, or anti-log, like if you write like a 10 to the power minus 2 is the 10 is the base and minus 2 is the exponents, and anti-log you can write 0.01. So it's both are the different way, but it's the real number, like if the functions like a to ax, and one is the a to the power x. So it's a graph of the exponential functions. If you write a to the power x, so it's a possible we can write this value. So let's how do we write this value. So I try to write the one value. So first I have a equation like y1 should be equal to, so y1 should be equal to 3 to the power x, it's a 3 to the power x, to the power x minus 1, x minus 1, 3 to the power x minus 1 and plus 2, it's a plus 2. So let's first I am going to represent like a x should be equal to, x will equal to np plus linear space plus np plus linear space minus 1 comma 2 comma 305. And now another. So first I have created a linspace, and now I want to put here y1 should be equal to y1, it should be equal to 3 to the power x. Another variable like a y2 should be equal to it's a 3 to the power again, and but x minus 1, like a x minus 1, and it's a plus 2. It's a plus 2. And now I want to visualize this graph. So let's see the graph 1 and another is the graph 2. So it's a working and not working. Yeah, it's a working. And now I want to visualize like a GRAPH1 should be equal to PLT dot plot dot PLOT and XY1 like a x comma it's a y1. And another graph like a graph 2. So it's a copy and paste. It's a graph 2. It's x and y2. And PLT dot legend PLT dot legend and handles like a graph 1 and graph 2. It's a handles should be equal to handles HDLES. So LEGEND and it's a handles. Yeah, you can write handles should be equal to graph 1 and graph 2. It should be equal to okay. So let's try. It's a working or not working. So I think I am getting a problem like a PLT dot legend. So let's go back. Now I am going to try here. Yeah, it has been plotted. So let's check it. Yeah, it has been plotted like both of these graphs. So similarly we can write, and we want to show the something x-axis, y-axis, each and everything we will show here. So I think now you are comfortable and you can understand how do we plot quadratic, cubic and exponential. Thank you very much.